This video shows how over a number of years the combination of individual vision and engineering teamwork at Silso Research Institute has been used to develop automatic milking and health monitoring systems to improve cow welfare and productivity. In a modern milking system, most tasks, except bringing in the cows, attaching teat cups and monitoring cow health, are automated. By the 1980s, the greatest technical challenge was the development of a robotic arm, suitable for moving under and in contact with the cow. An engineering team, led by Mike Street, developed the concept of a pneumatic robot that had the potential to be soft and compliant. The first robot showed the potential. It used a cow position sensor, a database of teat coordinates, and close contact electrical position sensing when the teat cup holder approached the teat. It clearly showed the potential for finding cows' teats and attaching the teat cup. A better robot arm, based entirely on pivoting joints, driven by linear actuators, was developed. It differed in design philosophy from the robotic milkers developed in the Netherlands. It picked up teat cups that could be left on the cow as in a conventional parlour. It was light and compliant, and it could be used to perform other tasks, such as teat inspection and cleaning. A valve control system and computer software to control it was needed to allow sinuous, smooth movements that would not alarm or hurt the cow as the robot moved below her. With the success of the pneumatic robot arm, it was possible to foresee how a fully automatic milking station could be developed to fulfill all the physical tasks that are currently done by the herdsman. A team of engineers and biologists was brought together to make the dream a reality. The dream was of a voluntary milking system, or VMS, that could perform all the functions of milking without harming the cow, but would the cows use it? We built a field laboratory at a research site in Berkshire, where we could conduct behavioural and engineering trials. We showed that cows volunteered for feeding either during or after milking. The position of the cow in the stall was gently detected, and the teat coordinates were adjusted accordingly. We showed that simple changes to the floor affected the position of the cow and the success of the teat cup attachment. We measured the dynamic movement of the cow's teats and demonstrated that the theoretical characteristics of the control system matched the requirements that worked in practice. The robotic arm used a database of teat coordinates that were continuously updated as the cow's shape changed. The robot approached the teat, controlled by an optical sensor. The commercial VMS has evolved an improved optical teat inspection and location system. Work is currently in progress to measure the health and fertility of the cow with biosensors for hormones and enzymes in milk. Teat cups were removed individually when milk flow ceased. This was better than conventional milking, where some teats are milked for too long. In the commercial VMS, this idea has been combined with the movement of the robot arm to guide the long milk tubes and prevent them becoming contaminated. Since 1994, we have concentrated on the monitoring of the cow health and fertility that is performed by the herdsman during milking. We have ongoing projects to develop a biosensor-based system to predict ovulation, to detect mastitis, and to measure the metabolic status of the cow. The cow is an Olympic athlete at eating, consuming the weight equivalent to a human every day. Managing the components of her diet is essential to allow her to produce milk and maintain her health. Cows naturally use their noses for selecting feed. And they soon learned that by breathing into a sampler above the empty trough, they received a food reward. We used this to detect subclinical ketosis. Our projects have followed a pattern of imaginative research funded by the research councils, followed by applied research funded by the Ministry of Agriculture, and finally commercial funding for technology transfer.